Hello, my name is Vinod. I'm a professor of computer science at West Virginia University. My team and I have designed Appioid, an easy-to-use app that could potentially save lives by connecting anyone who needs opioid overdose help with the nearest Naloxone providers, EMS, and family contacts, all within a matter of seconds. Because Appioid does most of its processing and storage on the cloud, it's naturally compatible with platforms like iOS and Android. In fact, we have also designed hands-free, voice-activated interfaces to use it with devices like Amazon Echo and Smart TV. Registration is simple both for Naloxone providers or help seekers. You enter basic details and register yourself as a provider if you're one. If you're registered as a provider, you will receive alerts when help is requested through the app. Once the user has signed up, all the information is sent to the Amazon Cloud database. Specifically, we use the DynamoDB software. The location of all signed-in users is dynamically updated. An update is triggered only when a user moves more than 10 meters, so no updates are generated when a user is static. This is the sign-in screen for our app. Once you sign in, you go to the landing page which presents 4 clearly marked buttons. To find the nearest pharmacies, to find the nearest hospitals, a video on how to administer Naloxone, and most importantly a button to request help in case of emergency. Now let us see how the emergency button works. Once pressed, a sound buzzer goes off. This is to potentially alert people in the vicinity even before the EMS or Naloxone providers arrive. At the same time, SMS messages are sent to the 3 nearest registered Naloxone providers. As we see here, the message contains the name, the phone number, distance, time for travel, and the GPS location of the help seeker, which can be opened on Google Maps for directions. Also, concurrently, a voice call is made to EMS.
This is an emergency alert. Alpha has a medical emergency. Phone number 68120939925. Latitude 39.6582. Longitude -79.9702. Please dispatch help immediately.
I will now describe the architectural design of the app that results in its scalability. When a user presses the help button, an event handler is triggered on the cloud system. The job of this handler is to simply compute the nearest Naloxone providers. But for this, it may have to potentially scan the entire database of Naloxone providers, which is not expected to be scalable. So we have divided the database into multiple small databases corresponding to each provider's geolocation. This way, the search has to be made only against a much smaller database which corresponds to the help seeker's current geolocation. This is the key to scalability in our design and faster response times. Once this subset is returned, the event handler then simply computes the nearest providers based on that sub-database and sends the SMS to those users. To handle scenarios in which a user may be incapacitated or may not have the phone handy, we also have a hands-free voice-activated interface through devices such as Echo and Smart TV. We demo this now. Alexa, ask Appioid to help me now.
Help is on the way and would be there shortly. Text messages have been sent to the nearest Naloxone provider. Send to your family contacts. Emergency medical services have also been notified.
This feature can be also activated through the Fire TV remote. We demo this now.
Ask Appioid to help me now.
Help is on the way and would be there shortly. Text messages have been sent to the nearest Naloxone provider. Send to your family contacts. Emergency medical services have also been notified.
We have also incorporated some useful data analytics features at the back end of our app. We have also written a web-based front end for analyzing this data. We show this on the screen here using some mock data to highlight this feature. On the screen, we see the help requests made in the last 1 month categorized by counties for males in the state of West Virginia. We can select other categories also. For example, we can select the age group 18 to 30 and we see that a new graph shows up. We can also track requests in real time. If we see a cluster of help requests for a short period of time in some neighborhood, a warning can be sent to registered users in that neighborhood. We believe that these data analytics features will provide valuable insights for agencies to optimize their Naloxone distribution efforts. We'd like to thank FDA for giving us this opportunity to design this app. We plan to collaborate with WVS Injury Prevention Center to help in the rollout efforts of Naloxone across the state of West Virginia.